Hello, future developers. Welcome to the continuation of our data visualization program. So today we'll be learning about boxplots. Okay, so boxplots help us to get some quartiles for our graph, okay, or values like representations. So first, we would want to understand certain things like np dot random. Okay, so gives us some random numbers. These random numbers are not predictable. So we have the seed function. Okay, then I'll put a value here 0. I'm going to put a value here 0. And then np dot random dot random and rand it's an n. Okay. So when I run it, let's see what happens here. So you can see we have this value. Okay. So if you run this program, you should have the same value. Let's copy it and then run it again, or let's just run it again and see what happens. Nothing changes. It's still the same value. Okay. So if this has no value, let me see. Let's run it and see. You can see it's changing. If I run it again, it should change. Okay. So if you input a seed, any number here, anyone having that same code would also receive the same number or value. Okay. So let's try something here. So let's say we want to create a one-dimensional array. So let me put any value here. So 2, and I'm going to put let's say 1. Okay, so when I run this, okay, I should get this value. Okay, so just one value for our row. Okay, so let's try put a comma here, and then I'll put let's say 2. When I run it, what should we get? So we have what 1. So this is our row. Okay, and then this is our column. Okay, so then put another value here. Let's say I want um let's put 10 here. When I run it, let's see what we have. So you can see we have 2 columns. Okay, so this is the first column. Sorry, this is the first row. It's our first row, and then our second row. Okay, and then the 10 here. So the first one is our row, the second one is our column, then the third one is our like the numbers we want our values to be. So the differentiations between the or the values that we want. Okay. Okay, so let's try something. Let me change here to 0. Okay, then I'm going to do here, let's say 2 comma 3. Okay, so we have what? One row, another row, okay, and then 3 columns. So the first column, second column, and then the third column. Okay, so 2 rows, which is first one, and then second one, and then 3 columns. Okay, so the first one represents the row, the second one represents the column. If I take this one out, we should have just 2 rows. Sorry. So one row with what 2 items or 2 values. Okay, now let's try. So comma, let's do here 4. Then let's do here, let's see 6. And then let's run it and see. Okay, so we should have 2 rows, 4 columns, and then values within this 6. Okay. Okay, so I'm hoping you guys understand this. Okay, so if you want to have so if you type in the same this, you should have the same values because I put a value here. If the value isn't here, okay, if I don't give it a seed, what will happen is it will just keep changing. Okay, it will just keep having different values. Okay, so if I put a value here, no matter the number of times I change it, I also get that same value. Okay, I should have that same value. Okay, so let's move to, so I'm going to type np, let's try plotting something, np.random dot seed, and then let's put 10 here, then put 10. Then I'll do, let's say I want, let's use info, so info equals np dot random that's normal. Then the normal I'll put 100 comma 20 comma 200. Then let me put, so let's create a figure. Okay, so a fig for the size. We want to create a fig for the size of our image. So plt dot figure, and then the figure size. Okay, what's the size of our image? So figure size. We want our figure size. Sorry, brackets. This would be a bracket. Our fig size to be, let's say, 15, 15 by, let me use 10. Okay, I need to close the parenthesis. Okay, and then let me do plt dot boxplot. So boxplot. Then as usual, we'll pass in our info. Then outside it, plt dot show dot show. Okay, so when I run this, let's see what we have. So we have this. Okay, so my fixed size is large. Let me change it to, let me use 8 by 8. Okay, so this is quite okay. You can see we have some outliers. Okay, like quartiles and the likes. Okay, so this line of code is going to give us, for this going to be our um, row, and then this is going to be our column, and then this is the values that we would want our numbers to be within, or to be with. Okay, so if we run this, no matter the number of times we run this, we'll get the same thing. Okay, because of the seed we have here. Now if I change here to empty and then I run this, anytime I run it, you can see now we don't have outliers. Our figure is going to change. Let's run it another time. So you can see it's changed again. Okay. Okay, so now let's try creating some um, multiples of this in one graph. Okay, so np dot random dot seed, and I'm going to put 10 here. Okay, so this is going to ensure that we all have the same values no matter what. The number of times you run it will get the same thing. So let's create info. I'm creating an, so let me use info one. Okay. Then I'll do np dot random. Then let's put some values. So let me say I want 10 comma, I want 20 comma, and then I want let's say 70. Okay, so I'm going to pause this and then duplicate this 3 times. Okay. Okay, so I've populated this. All I have to do is change this. Let me say info 2, info 3. So these variables info 4. Okay, and I gave them some, oh, I should have done dot normal, and pause the. Okay, so the normal is just going to help us with us getting like a normal distribution of data. Okay, so this what I did. I just changed the values and then add the normal. Okay, created a variable with these names. So now what we'll do is let me create, let me store them in something called, let's say, all. No, all is the keyword. So data equals, and then create a set. Sorry, a list. Okay, and then we want to store all our info inside. Okay, so we are storing this. Okay, our variables inside this data, which will be called later in the code for us to be able to draw the box plot. Okay. So all I have to do is to come here, pick this. I'm going to paste it here. Okay. Then next what we'll do is to, okay, so now we'd want to set the width and height of our plot, just so we have the different the random values, okay, inside our like different box plots. So to do that, let's create axis, or let's see, axis would give it some, so fake dots, and then we use the add function. So add underscore axis, so add underscore axis. Okay, Okay, so this okay, so this is a function in Python like NumPy. Okay, so this as this isn't referring to this. This can be any variable name. Okay, so this as this is a function in NumPy. So the first argument, I'm going to say 0.75. You can use any value. Let's say you can use 0. I'm using, so I'll use 1, comma 1, then comma 1. Okay, so I have 0 for our x min, and then 0 for our y min, and then here is going to be the height, and then this one is going to be the width of our box plots. Okay, then let's create a variable to help us draw. So I'm going to use let me just use draw as this dot box plots. Okay, so data, remember which one is data? Okay, you store it into data, and then all we have to do is to plt.show, and then let's see what happens. Okay, so you can see we've generated a box plot. Okay, showing the medial outliers. We have our percent, is it percent quartiles, median, and the, like, yeah, these things for standard deviation and the likes. Okay, so there's box plots. I think my size here is too big. Okay, so you might want to go over this video again to actually understand what these values stand for, okay, or parameters stand for. Okay, so thank you, and then I'll see you in the next lesson. Thank you.